Modern urban life runs on a fragile web of interconnected systems. When the power grid, supply chains, or communication networks falter, the stability of a city can vanish in a matter of hours. Cascading crises, from floods and fires to economic collapse and pandemics, are no longer distant possibilities. They are specific, catastrophic threats that test the limits of our modern infrastructure every year. For decades, Thailand has relied on the Kok Nong Na agricultural model to build resilience. It is a proven system of water and land management, but it presents a significant spatial barrier for the 21st century urbanite. A standard Kok Nong Na setup typically requires 2 to 3 rai of open land, roughly 3 to 5,000 square meters. That scale is simply impossible to achieve within a dense city grid. The Operation X Learning Center in Ayutthaya was designed to break this spatial limitation. A team of youth innovators has successfully condensed a functional survival ecosystem into a microplot of just 50 square wa, about 200 square meters. Survival in the modern era is about engineering these resilient systems into the existing urban footprint, rather than escaping to the countryside. This blueprint begins by hardening the microplot against the 3 primary forces of nature: floods, fires, and storms. The team uses 3D modeling and virtual reality to simulate disaster scenarios on the plot before any physical construction begins. They stress test the layout digitally to find the most efficient spatial configuration. To counter floods, they calculate historical water levels to design an elevated mound for the home. This keeps the core living structure above the waterline, while the rest of the plot manages the excess volume. For fire protection, they utilize winding chicken intestine canals. These narrow, water-filled channels encircle the property, acting as fire breaks designed to starve an approaching blaze of fuel. To handle storms, the team selects trees based on root architecture. Deep-rooted, interlocking species are planted at specific intervals to block high-velocity winds and anchor the soil. This technical layout integrates solar power, water storage, and vertical agriculture into a single high-efficiency model designed specifically for crisis management. With this approach, surviving a natural disaster becomes a matter of precise, data-driven architecture. The second layer of the blueprint addresses systemic collapse, scenarios where war, lockdowns, or energy crises sever the city from the national grid. In a total grid failure, a microplot must be able to communicate and manage its own resources without external assistance. The team utilizes LoRaWAN technology and ESP32 microcontrollers to build an independent communication network. This allows for off-grid data sharing and coordination that does not rely on the central internet provider. Energy security is managed through DIY solar arrays paired with a localized pyrolysis system. The pyrolysis unit processes plastic waste and biomass in a high-heat chamber. It produces biochar, a solid carbon material used for rapid soil enrichment to maintain food production in small spaces. The system also captures liquid byproducts, oil and wood vinegar. These provide a reliable source of backup fuel and natural pest control when commercial supply lines are non-functional. Urban resilience is achieved by creating a localized circular economy that functions independently within your own walls. Operation X functions as a live research and development engine. This is a living lab where workshop participants are utilized as active co-researchers. As participants interact with VR planning tools, LoRa networks, and pyrolysis machines, the team collects user data and identifies friction points. This data is processed by an AI analytics system supported by the Panya Pradit Institute to find weaknesses in the current model. This feedback loop allows the youth innovators to identify flaws and release an upgraded version of the 50 square wa blueprint every quarter. Combining traditional agriculture with youth-led hardware and AI, Operation X proves the smallest urban plot can be engineered into an evolving, resilient survival site.